Hi, I'm going to walk you through the notes on the B change. So this is for the A-level performance task. So you should have already received this paper from your teacher. We're going to flip it over and you'll see there is another version of what you had on your old foldable. On your old foldable, we just had the A, H, and K. On your new one, we've thrown in B. So the first thing I want you to do is highlight, and you're going to need a green highlighter. You need to highlight all the B's. And what I want you to notice is that B is grouped with X, but it's not after it, it's right in front of it. So that's the first thing you're going to have to know, is that B is grouped with X, but it comes right before it, but it's not after it like the H. Okay, so we're going to flip it over and we're going to highlight this B so that they're all green. All right, that's the first thing we're going to do. So the first thing was the location. The next thing we're going to do is talk about how it affects the graph. So go ahead and open up the foldable. And we're going to take these notes and then you're going to do some practice. And you can always come back to the notes while you're doing the practice. I definitely would ask for clarification from your teacher if you need it, because some of the stuff I'm about to show you can get confusing. So to name B from the equation. So the first thing you need to know to name B is that you name it exactly as it appears. So name B exactly as it appears in the equation. So just like A, just like K, name B exactly as it appears. So for example, if I have the equation y equals the square root of 1/3 x, my B is 1/3. So you're going to name it exactly as it appears. So far, so good. But when we go to describe the transformation, we're not going to describe the transformation from the B. The first thing you have to do is you have to name the reciprocal. So just a reminder, the reciprocal is not the opposite, it is the flip of the number. So you're going to name the reciprocal of B. So again, let's go with this example here. If B was 1/3, my reciprocal is 3. You don't need to write 3 over 1, but that's truly mathematically what it would be, but we don't write the divided by 1. So you flipped it upside down. The numerator becomes the denominator becomes the numerator. So once you have the reciprocal, and I'll number these, we'll name the reciprocal first, and then the second thing you do is you're going to describe the reciprocal, not the B itself. You're going to describe the reciprocal and how it affects the graph. So this is why it gets a little bit confusing. We name B as it is, then you name the reciprocal, and now we're going to describe the reciprocal. Now this is going to be very similar to what we did with A, and I'm going to keep using the word reciprocal. If you want to abbreviate it like recip or something shorter, then that's totally fine. So here's the description. Like I said, very similar to A, except now it's horizontal. So if the reciprocal is negative, it's going to flip over the y-axis. So that's different than the A. The A flipped over the x-axis. So if the reciprocal is negative, it flips over the y-axis. If the absolute value of the reciprocal, so now you're looking at it without the sign, if the absolute value of the reciprocal is greater than 1, so look at it without the sign, if it's bigger than 1, that is going to be a horizontal stretch. And as you could probably predict, if the absolute value of the reciprocal is between 0 and 1, that's going to be a horizontal compression. Okay, so we name it exactly as it appears, then we do the reciprocal, and then we're going to describe the transformation based on the reciprocal itself. All right, so now we're going to talk about how to use it. This again is somewhat similar to A in that we're going to apply it to the table. So you're going to multiply each x value this time by the reciprocal of B. By the reciprocal of B, not B itself, not the B that you named, but the reciprocal of it. So you set up your parent table just like before. Just like before, we set up our parent table. Now we're going to multiply the x side. So we're going to multiply the reciprocal of B. I'm going to call it recip of B times x. If you don't like that little times sign, you could make it a dot. But it's multiplication. And then, just like we did with the A, once we applied it to one of the columns, we cross that column out. So when you go to plot, you plot the new x with your y. Okay, and remember, throughout the video, if you need to stop and pause it or rewind it because I'm talking too fast, go ahead and feel comfortable doing that. It's not any kind of rush. All right, now we're going to move on to an actual example. So here's our equation. We've got a cube root, and my parent equation is a cube root of x. Now, this is where we're going to name B. It is exactly as it appears. So it's -4. Exactly as it appears. But before we describe the transformation, I'm going to name the reciprocal. And the reciprocal of -4 is -1/4. It's -1/4. So based on my reciprocal, I can now describe the transformation. First of all, it's negative. So I know that's going to be a reflection or a flip over the x-axis. Either word is fine. I'm sorry, y-axis. I misspoke. Y-axis. Reflection over the y-axis. And when I just look at my reciprocal without the sign on it, 1/4, that's between 0 and 1. That's going to be a horizontal compression. Now, it's going to be really important in your practice problems that you're actually being clear about when it's a horizontal compression versus a vertical compression. So you're going to reflect over the y-axis because of the negative, and it's going to be a horizontal compression because of the 1/4. All right, so now we've got to set up our table. So this is the cube root. So I know that my points are going to be the cube root parent points. Those are the cube root parent points. And now I'm going to multiply all of the x's by -1/4. So I'm going to multiply x times -1/4. So -1/4 of -8 is a +2. -1/4 times -1 is a +1/4. And again, if you prefer to use decimals, that's totally fine. Anything times 0 is 0. -1/4 times 1 is -1/4. And -1/4 times 8 is -2. I'm done with those old x values, and now these are the new values I'm plotting. And again, you'll notice that we're going to end up plotting fractions. That's totally fine. You're just going to have to estimate where they are on the graph. So I'm going to plot 2, -2 right here. 1/4 is not that far, and then down 1, 0, 0 did not change. -1/4 is a little bit to the left of 0, and then up 1, and then -2, 2. And remember, when you connect this, you don't want to play connect the dots. You want to connect it smoothly. We'll see how smooth I can make this. Okay, that's not bad. And you want to extend it through the dots. So I can look back at my description and say, okay, did it reflect? Yes, it's going a different way than the parent, and it definitely got compressed horizontally. So remember, horizontal compression is going to be compressing it from side to side. All right, so your job now is to do the practice problems. But I want to warn you that your practice problems sometimes involve also an A change, which you'll still multiply on the right-hand side. So the first practice problem is just a B change, and the rest of the practice problems are an A and a B change together. So please ask your teacher if you need any help. And that's the end of the video. Thank you for watching.